हाय हेलो एवरीवन, मेरा बच्चा लोग कैसे सब? हाउ आर यू ऑल डूइंग? जल्दी से जल्दी बता. आई एम लुकिंग इनटू द चैट बॉक्स. आई वांट टू नो हाउ ऑल माय वैरियर्स एंड लेजेंड्स आर डूइंग. लेट मी नो हाउ अमेजिंग द डे वाज. जल्दी. सो हाय पलक, गुड इवनिंग. इमाद. Then do we have a DJ, then Killer. Okay, so many that kind of fancy names we have, right? So Sudeep, we have Harsh. So we have so many amazing people here in the classroom, isn't it? And let me ask you, in yesterday's class mainly we were discussing about the combination of resistances and finding out the equivalent value of resistance by using different tricks and tips. So let me ask you, how many of you have did the revision and did some extra multiple choice question? Jaldi fatafat bol de. How many of you have did the revision of yesterday's topic, whatever we have done? Because I have told you it is one of the important topic, isn't it? Yes, Palak, you did the revision. Very good, badhiya baat hai. And in today's session, we will be mainly dealing with what? The combination of cells, which mean how the cells can be connected in different ways, such as series connection, parallel connection, what is the effective value for EMF going to be. So many things we are going to discuss in today's class. I hope you all are ready, hai na? So whoever is seeing me for the very first time, this is Ameer and my students call me with full of love Ameer Bhaiya and physics educator at Unacademy. I hope you can see a bit of introduction about myself on the screen, right? I have an experience of more than 3.5 years in the field of teaching JEE, NEET and board student. I am a BTech graduate from NIT Calicut and I taught and mentored many students from throughout the country, and here I am. Okay, now let us wait for every one of the students to join, and in the meanwhile I'll give you a brief introduction about the Unacademy platform. Okay. So here you can see the schedule. Right, today we are on 13th of October. We are having Cells 2 and Kirchoff Law we'll be discussing. Tomorrow it will be complete discussion about Kirchoff Law and doing the multiple choice questions. So don't miss tomorrow's class at 10 p.m. Okay. And you know that amazing teachers of this particular country are teaching you live in Unacademy Class 11th and 12th YouTube channel. And I know that you would love to catch them live all the time whenever a class happens. So that's why we have this Telegram channel where every notification and updates will be given to you so that you can join your favorite teachers live on the time without missing any of the classes. So don't forget, this is the link is given, click on it and be a part of it as soon as possible. Jaldi se turant. Okay, then you know that for the term 1 examination of CBSE, we are going to be having what? A new examination pattern with multiple choice questions and assertion reason type question. Many of us are not so much comfortable with this kind of examination. So what we need a huge practice so that once we go to the exam hall, we'll be giving in an amazing way, we'll rock the exam and we'll be coming out with the maximum marks, isn't it? So that's why Unacademy, who love their students, have made this Emerge program, where in every week live mock test will be there for every subject till the term 1 examination happens, and those who gets amazing mark, you will be so famous, let me say, because you will be there in all the Unacademy social media handles. So the respective dates and the time you can see, it is completely free, and if you want to enroll for free, what is the code you have to use? It is AMB10. Use this code of AMB10 and enroll for Emerge, which is completely free, and try to practice and improve yourself and make yourself stronger for the upcoming term 1 examination. I know that you all are going to do, right? Okay, give me some 2 minutes. Okay, then we are, after this we'll be starting with our classes. In this 2 minutes I'll be talking about what the special features of this Unacademy subscription. I'll be telling in all my classes, many of the teachers will be telling that why Unacademy subscription is so much important. I'll tell you, okay, because you know nowadays everything is available for free in YouTube. Some of the amazing features which makes Unacademy subscription so much amazing is that, right, we all educators in the Unacademy platform will be teaching with a proper schedule targeting JEE exam, board examination, NEET examination, and we will make sure that all the topics are in proper order that we teach in the Unacademy subscription platform. So once everything is in order, you can keep track of all the topics that we learn. And what happens? Yes, the entire process of learning will become super simple. So you'll start enjoying the subject, each and every subject you'll start enjoying your studies, and you will give your maximum effort, and all these will end up in giving you an amazing mark for all the examination you're going to write. Top educators of the country who are having very good experiences, and those who are having a very good idea about the examination pattern and the kind of question that is going to appear for the exam, is there already within Unacademy platform. So if you start learning with them, they'll just tell you the path that you have to follow so that you can end up in the destination colleges whichever you want. Study materials will be given to you. Practice test and live test series will make you super confident and will bring out the best from every one of you. So for this plus subscription, for enjoying all these features, if you're going for 9-month subscription, it will cost you 1,444 per month. And as you all know, I'll be there, and I'll be there to help you to get a discount of 10%, and the code is AMB10. Don't my M almost looks like a N, it is actually M, okay? So it is AMB10, use this code and get 10% of discount. So I have described all the features. If you want all those features and some extra features while you learn with Unacademy, you should be going for this Iconic, because in Iconic subscription, extra features such as a personal mentor will be given. What is this personal mentor thing? It's an amazing feature, let me say, because a person will be assigned to you. That person will be there throughout your year, and that person will be there telling you how to study, what should your schedule should be. For everything, this person will be there to assist you. So your process of learning will become half. Okay, then live doubt solving classes will be there, weekly reports will be given to you. So for enjoying all these amazing features, you should be going for Iconic. For 9 months of Iconic, it will cost you 2,556 per month, and the code that you want to use for getting a 10% of discount is AMB10. Use this code, get 10% of discount, have a smile on your faces, and be a part of Unacademy. 2 reasons to be a part of Unacademy for that right now, which means if you become part of Unacademy right now, 2 amazing offers you can enjoy. First thing is, you will get extra 4 months CBSE subscription and a Creative Corner subscription, one thing. Second thing is, if you start learning now, you can complete your entire syllabus before all your examination, what are you going to write. So that is something important. So be with Unacademy, start learning, complete your entire syllabus and prepare well for all the examination. And I want all my warriors and legends to pass their examination with flying colors. Okay, that's all about everything, and now it's time for our studies. Tell me, how are you all doing and how is the Josh? Hi Nikita, Harsh. Okay, Palak, we have Sanchana. Then we have Anna. So tell me, are you all ready for the session to get started? I can't see that energy. If you are not so much energetic, if you are not having that excitement in your chats, it will also give me a bad vibe, isn't it? So yes, full Josh. Satya is like, sir, we are with full of energy. Now it's your responsibility to give us all the information, whatever is required, isn't it? So tell me, how we regularly start with our classes? How we start? With a small recap of what we have learned, isn't it? Ready? So shall we start in the same way? Shall we start in the same way? Sir, depress he whom? Why you have to be depressed? Just come in the class, chat with all your students and have a smiling face, learn everything whatever you wanted, enjoy your life. The life is all about to enjoy, not to get depressed. Enjoy your life. Okay, so here we go. Okay, so let us discuss about what we have learned in last classes. In the last class, the main topic of our discussion was finding out the equivalent value of resistance. Tell me, which are all the laws which we have learned in the previous classes, one by one, by using the basic equations. If resistances are connected in series, we can use a formula of R equal to R1 plus R2 plus R3. This is the basic formula if connected in series. If they are connected in parallel, formula is 1 by R is equal to 1 by R1 plus 1 by R2, 1 by R3 if they are connected in parallel. Okay, then after this we have learned so many tricks for solving the circuits, isn't it? First one was rule of symmetry. First rule was, yes, perpendicular rule of symmetry. If perpendicular rule of symmetry exists, along the plane all the points will be having the same potential. We did so many questions. Those who missed, please do watch yesterday's session. Then parallel rule of symmetry, and if there a parallel rule of symmetry exists, yes, all the mirror points will be having the same potential. Those who missed, please do go and watch this. All these are important. And the third rule of symmetry is current rule of symmetry, right, which we have learned in yesterday's class. Then was there any simple method? Wheatstone bridge bhul gaya. Wheatstone bridge condition, if P by Q is equal to R by S, we will say the given Wheatstone bridge is in balance situation, and we can remove that fifth resistor. We have learned, right? We did lot many problems also. So those who missed any of these topics, please do watch. Make sure you learn this. It's really important. That's why I am telling you again. And I know that all my legends have done extra revision and did as many multiple choice questions as possible. Then it was in yesterday's class we started with cells, isn't it? Tell me. So we are going to continue with cells. Tell me, if you are having a cell, it will be associated with an EMF. Will there be a resistance offered by this cell? Yes. What do we call that resistance? We call it as internal resistance. Mark it with a small r. So this together is our cell, because cell will always be coming with a small resistance that it offers to the flow of charges. We usually call it as internal resistance, and it is this cell which we will be connecting across our main external resistor capital R. We have learned something. We have learned that the net potential difference across a cell is not E. How much is it? That is E minus IR. Yeah, IR kya hai? IR is the potential drop across the small resistor. So from the total potential, if you subtract this IR, the potential dropped across that chotu resistor, we will get the total potential difference V, which is across the given cell. Okay, and it is this same V which will be dropped across the external resistor also. Isn't it yes or a no? Yes. How to find out the current in the circuit? Array, current is equal to total potential difference. How much is it? E divided by total resistance. One R, another R in series. So total is R plus R. So it was till here. We have completed our discussion, isn't it? Yes or no with a smile. Jaldi se bol de. Haan sir, bilkul. How many of you think that you can do a problem based on this? A chotu sa problem where you have to apply some application level concepts also. How many of you do think? Sure, I can do it. Let me see how many of you do have that daring mentality to do a problem. Yes, Palak is ready, Myara is ready, Sanjana, Sankamitra. So all my amazing legends and warriors in the classroom are so ready. So here comes a question. Give me the answer. Amishi, yes you can. Okay, so whoever have given me the promise, it's your time to tell me what the answer is. Go for it. We can and we will. Wow. That's an amazing motivational line, Myara. Good. You can do it. Yes, Anjana. And whenever anyone in your life asks you whether you can do it, let's have that daring mentality and say, yes, I can do it. Okay. All my warriors and legends should be that strong. Anyone with the answer? I'm looking into the chat box. Okay. So you are actually deviating me by other comments. I was actually looking for the answer, but I'm not able to find. Yes, Nikita says it's option B. Then others? I can see Nikita's answer. I'll wait for one or two more persons. Okay, Shastra says option B. Very good, amazing. The correct answer is option B. Shall we understand? Everyone listen. A battery is there, EMF E and internal resistance R. It is connected to a variable resistor R as shown here. I'll just draw the figure for you. Which one of the following? Which means the question is, power delivered to the resistor is maximum. At what condition the maximum power is delivered across the external resistance R is the question. Okay, so let me take a fresh page. Everyone open your notebook, try to write down every point what I say. Listen, here we have a cell of EMF E with an internal resistance R. This is connected across a resistor. Is it a constant? No. It is a variable, which means we can keep on changing the value of this external resistor. Okay. Question is, for what value of R the power will be maximum? फटाफट बोल दे, what's the formula for power across a resistor? I square into R. Many of you will be looking into this equation and will be telling the power will be maximum when R is maximum. If you keep on increasing the value of R, power is going to increase. Many of you are going to think in that way, right? But that's a wrong thing. Can you see this I? Do you think this I is dependent upon the resistance? Yes. What's the formula for I? I have already told you. The current is equal to potential difference E divided by total resistance R plus small r, the whole square into R. Now you can see that power is not only dependent or directly proportional to resistance, it is inversely proportional to the capital resistance also. So we cannot say that if we increase the value of capital R, the power is going to increase, because in the denominator also we have this capital R. So how to do it? Any idea? Any idea on how to deal with this? Arre dekh le. So you can see that power is dependent upon this capital resistance on its numerator and denominator. So what we can see is initially it will be having an increase if a graph is plotted between power and resistor. Initially, if the value of R is increased, you can see power will be increasing, it will be reaching the maximum and then it will be increasing. So a graph between power and resistance is going to be looking like this. Can you see that point which we actually require? Can you see that point? I can see this point. Yes. And what is the specialty of this point? It is at this point where you can note the maximum value of power, and this is obtained at a particular value of R0. Don't you want to find this? Yes. If you want to find this, tell me what the specialty of this point of the graph. Can you find any specialty for the point on the graph? Any specialty for this point? It's very simple. Isn't the slope 0 at that point? Isn't the slope 0 at that particular point? Yes, bachcha log, the slope is 0 at the point where we have the maximum value of power. And how do you write? Slope is equal to dy by dx. Chota class, we know that differentiation will give you the slope, isn't it? Yes. So d, what is on the y axis? Power. By d, what is on the x axis? R. So dp by dr for this graph of power and resistor will be 0 at the point where we have the maximum power. Let us substitute d by dr of p. What is the value of p? E square by r plus r the whole square into capital R. Fatafat kar le. You are 12th standard students. You also know that. I also know that. You know differentiation better than me. Jaldi se bol de. Uttar. E square is a constant. It will come outside. Okay. And differentiation. Okay. Division rule of differentiation is r plus r the whole square into differential of numerator. What is the differential of r with respect to r1? Minus numerator into differential of the denominator, that is how much? 2 times r plus r the whole divided by r plus r square the whole square, and it is given that this slope is equal to 0. For what point? For the point where we have to find the power max. Arey jaldi se kar le, I can't see the answer. This is not the students what I am asking for. I want everyone to give me the answer jaldi. Okay. So what is the only probability of this particular equation to be 0? If the numerator is 0, isn't it? What is on the numerator? R plus r the whole square minus 2r into r plus r is equal to 0. Okay. Rearrange kar le. If you take this to the right hand side of the equation, how much it will be? R plus r the whole square is equal to 2r into r plus r. Array 1r plus r, 1r plus r will cancel. So what will be remaining? Let me write it here. I hope you all can see. R plus small r is equal to 2r. So r cancel, r is equal to small r. So we got the power will be maximum when chotu r is equal to capital R. बस समझ में आ गया? समझ में आ गया तो मज़ा भी आ जाएगा and you all will be so busy writing this down. जल्दी बोल दे. Tell me. हाँ, done. Note it down with a smile. Perfect. Okay, ठीक है. So I just did this problem so that I want to know how much you all have revised with yesterday's topic. So which is our option? Our option is B. So many of you have given the answer. I'm so happy. Noting down. Okay, so if it is taking too long, please take a screenshot. Okay, noted. Sankhamitra, Agni, Satya. Yes. Now shall we look into the combination of the cells, which is one of the important topic. Okay, which is one of the important topic it is. So we know everything related to the combination of resistors and finding out the equivalent value of resistance, isn't it? Yes, we all know that. Now what is left is the combination of cells, which means if cells are combined, what will happen to their EMF? Okay, how their internal resistance are going to change, and all these things is what we are going to learn. Okay, let's see. First we will discuss about the series combination of the cells. Everyone take a very fresh page and start noting it down. So you have a cell E1 with its internal resistance R1. Let's say if this is connected to another cell in the same fashion of EMF E2 and internal resistance R2. If I ask you what is the total EMF, anyone can tell me. What will be the total EMF? What will be the total EMF? Sir, you are genius, sir. I hope you are not making fun, है ना? जल्दी बोल दे. Anyone with the answer? Just guess. It's very easy. If two cells of EMF E1 and E2 are connected in series, what is the total EMF going to be? Not at all a big task. Nobody know the answer. Meanwhile, you give me the answer, I'll just drink a water. Nobody. Alright, two cells EMF E1, E2, which means we have two potential differences connected in the same order. What will be total EMF? Very good, Ayush, Amishi, Sankhamitra, Satya, Anna, Sanchana, happy go. This is what I want, right? So the total EMF will be the addition of EMF of both of them, which means E1 plus E2. Similarly, what will be the net internal resistance? First one is having an internal resistance of R1, other is having R2. R1 plus R2. Is there any issue? No. Two resistors connected in series. That's the only thing. So if two cells are connected in the same order, EMF will get added up. Okay, because the potential is supporting each other, isn't it? Dekh. This is trying to produce a current in this direction from the positive end. This is also trying to produce a current in the same direction towards right, which means the EMF is actually supporting each other. So how many of you can tell you have a cell of EMF E1? Its resistance is R1. Another cell is having EMF E2. Its internal resistance is R2. Now tell me, what is the value of EMF going to be in this case if cells are connected in the opposite order? Can anyone tell me? कल 10 बजे इसके आंसर दे दे पहले जल्दी से तुरंत with a smiling face. Let me see. What will be the equivalent value of EMF if cells are connected in the opposite fashion? Just make a guess. Very good, Ayush. Very good. I'm so happy that so many are here and ready to give me the answer. Very good. Just use your common sense. E1 is trying to produce a current towards right. E2 is trying to produce a current in the opposite direction. So are they supporting or opposing each other? Opposing each other. So net EMF is E1 minus E2. But what about resistance? Resistance is so happy all the time. There is nothing like supporting or opposing. Resistance is always opposing, whatever may be the case. So the equivalent value of resistance, as both of them are connected in series, is R1 plus R2. whether they are connected in the same order, opposite order, nothing will happen to the internal resistance, only the EMF will change. Okay, so very important, so many questions you can get it from here. Okay, so 10 seconds you all have. Sumit, thank you. Harsh, you are back. Good to have you back. So I hope you all have noted. कोई doubts है क्या? Any doubts, anyone? Any doubts? Nothing, I suppose. Okay. So with the permission of all my various and legends in the classroom, I am moving forward. Noted, right, Agni? कल पूरा अरे बाप रे, what happiest news can I receive other than this, Rajput? Amazing, no doubts, right? Anyone? And everybody have noted this down. ठीक है. So tell me. Okay, now let's do this. If n cells, okay, everyone give me the answer. If n cells of equal EMF are connected in series like this to an external resistor, what is going to be the net EMF, net resistance, and the net current? Very simple. If all these cells are connected in series in the same order, EMF will be equal to E plus, E plus, E plus, E plus, E plus. So if n number is there, effective value of EMF is equal to n times E. Any problem in this? No. What about the resistance? R plus, R plus, R plus, R plus, R plus. If n number of such internal resistance are there, equivalent value will be equal to n times R, R equivalent. Okay, and this is only the equivalent resistance of the internal. Along with it, one more external resistance is there. So total R equivalent, total resistance in this entire circuit is total internal resistance NR plus the external resistance of capital R. So now tell me, what is the equation of current going to be? Current I is total EMF by total resistance. Total EMF is NE and total resistance is NR plus R. मिल गया, आंसर तो मिल गया. No doubts here, I suppose. है ना? I don't think there has to be a doubt because you all have understood the equation to find out the series combination of resistors, isn't it? Hi, Adventure World. So this is the time to start doing the problems. Here you have, I know some options are not visible to you, I'll redraw it here. Okay, option A is 7.2 volt and option C is 6.8 volt. जल्दी कर ले, मिल गया तो मिल गया, आंसर तो मिल गया, खुशी भी आ गया, और क्या. So go for it, everyone in the classroom. I'll also read. Okay, a battery has 6 cells in series and each cell has an EMF 1.5 volt. Okay, and an internal resistance of 1 ohm. If an external load of resistance 24 is connected, the potential drop across the resistance is. What is the potential drop across the load? That's a question. I don't think it's a very big deal. It's actually a simple question. Let me see who is going to give me the answer first. Nikita says it's option C. Harjod Nesra says option B. And Miara says option A. Any other options? The only option that is left is D. Do anyone want to take that? We don't want to make the option D left out, right? Because we don't want to make the option D to be so sad. Anyone want to take the option D? That is the only one left. Very good. Many are giving option A right now. Prateek, Miara, Sudeep, Palak. Okay. So yes, very good. So yes, the correct option is option A. Let's see. You know that 6 cells in a series are connected. So the total EMF is equal to N times E. We always know that effective value of EMF. How many are there? 6, and each is having 1.5, which means 3 by 2. So this ho gaya 9 volt. So the effective EMF is 9. Internal resistance is 1 each, and how many are there? 6. So total value of R is 6 times 1, that is 6 ohms. Okay. If an external load R is equal to 24 ohm is connected, potential drop. Tell me, how will you find out the potential drop across a given resistor? Very simple. The current passing through it into its resistance V equal to IR. है ना? और क्या? So, how to find out? अरे मेरे गले को क्या हो गया? Okay, ठीक है. So, the potential across any given device is equal to the current passing through it into its resistance. Tell me, what the equation to find out the current passing through a resistor? The total current is equal to total EMF 9 divided by total resistance, that is 6 plus 24, because all are connected in series, that is 30. So this is the current. So V divided by total resistance into the resistance, how much is it? 24. हो गया. So you will get the answer as how much? 7.2 volt. बस हो गया. Okay. Yes. क्या हुआ तेरा वादा? समझ में आ गया नहीं आ गया? इतना simple question. Don't say that we didn't understand. यो म्यारा. Okay. So मजा आ रहा है क्या? Which means understanding the concept and doing the problem. Are you able to understand in a better way? जल्दी फटाफट बोल दे. Right, I suppose, right? Let's do more. Okay, very good. So go for it. It's actually a simple question, or where you have to apply a bit of common sense, let's say. I'll rewrite all the options here. Option A is 4 times E and 4 times R. Option C is 2 times E and 2 times R. बड़ा वाला स्माइल पलक, और क्या? इतना बड़ा है क्या मेरे जैसे? वेरी इजी अर्जुत. ओके, ये भी कर ले. एनीबडी विद द आंसर फॉर दिस? निकिता सेज ऑप्शन डी. ओके राजपूत, बढ़िया बात है, बढ़िया बात. I'll wait for you. Okay, maybe I should start asking questions before starting with the classes, so that I can understand how many of you came to the class after revision. Anyone with the answer? It's very simple. Simran says option D. 2 are going with option D. Anyone with other options? हर्ष सुमित भैया की गैंग का को लीडर. ओके ठीक है, लीडर बता दे. यू सेज ऑप्शन बी. ओके, म्यारा says option B, Harjot says option B, Nikita says option B. So many are giving me option B. Let's see whether it is true or not. Shall we read? 4 identical cells of EMF, internal resistance R, are connected to be in series. Okay, we know that. Got it. Suppose if one of the cell is connected wrongly. Wrongly matlab in the opposite order. What is the equivalent EMF and internal resistance? Okay. First one, internal resistance. Second one, its internal resistance. Third one, its internal resistance. Fourth one is connected in the opposite order with its internal resistance. Okay, all are having the same EMF, E. So how much will be the EMF? E plus second EMF plus third EMF, but the fourth one is connected in the opposite, so minus E. So how much is it? So E minus E, these two will get cancelled. What is remaining is 2E. हो गया. And what about internal resistance? Is there any negative thing gonna happen here? No. Resistance is always opposing. Whatever happens in the world, a bad influencer will always be a bad influencer, isn't it? He'll always be giving a bad influence to the remaining people. Similarly, if it is a resistance, its duty to resist the flow of the charges, and it will be doing whatever is happening externally, right? So the resistance keep on getting added up. So it is R plus R plus R plus R, which is 4R. हमारा आंसर हो गया ऑप्शन बी. इतना simple. Okay, so this is the maximum kind of questions you should be expecting from series resistors. Is it fine? I know that you all will be like, sir, और क्या, इतना simple था. 2E and 4R. Very good. Sir, are you from Kolkata? No. I'm from a place with the same letter starting, which means K. Do you want to make a small guessing from where I am? Okay, I'm from Kerala actually. More questions, you will get more questions once we deal with the parallel combination of cells also, because when it comes to parallel combination of cells, the questions will be a bit more difficult. You will understand, okay, everyone will start enjoying it, because the parallel combination of cells is a bit more difficult in while we compare it with a series combination. Okay, so here we go. So this is white color pe we need a black color, let's say. So we have one cell of EMF E1 and its internal resistance is R1. Okay, we have another cell EMF E2 and its internal resistance is R2. How they are connected? SA in parallel, and this combination is connected to an external resistance of R. Question: what is the effective value of EMF? What is the effective value for resistance? Those who need only the formula, just you can note it down. EMF is equal to, net EMF is E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2, and R equivalent 1 by R is equal to 1 by R1 plus 1 by R2. Understanding the equation for resistance, it's not a big deal, because R1 and R2 you can see that connected in parallel. So I have used the equation for parallel combination of resistance. 1 by R is equal to 1 by R1 plus 1 by R2. This with this equation for finding out the equivalent value of EMF will be new to you. So those who just want the equation, please note it down, because I would always like to explain the concept, and I don't know how many of you find it boring, but physics without concept is zero. Okay, so I'll explain how the equation of EMF is E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2. Okay, so try noting down along with me, and it's very important. Here we go. Now E1 R1 E2 R2, let's say across the ends of this combination there exists a potential difference of V. Okay, across a point there is existing a potential difference of V. For calculation simplicity, I am expressing this potential difference as 0 comma V, okay, at the extreme ends. So here it is 0, and let's say this is V, which will be producing a potential difference of V minus 0, it is V. For calculation simplicity I have written. Okay, now a current of I, let's say, exists in the circuit, in the main circuit. I comes, reaches at the junction. What happens? Obviously it will be branching out as I1 and I2. So is there any relationship existing between I1 and I2? Obviously current I1 is actually splitting as I1 plus I2. So I1 plus I2 will be giving as I. Okay, define I1. I1 is the current passing through resistance R1. How will you write the formula for current? Potential difference by the resistance. Current is potential difference by resistance. So I1, the current passing through the first resistance, what is the potential difference across it? E1 minus V divided by its resistance, plus I2 is the current passing through second resistor. So its formula will be E2 minus V divided by R2, similarly according to what we have written. Any issues? No, I suppose, right? Okay, let me rearrange. E1 by R1, can you see? E2 by R2. Okay, minus V by R1 minus V by R2. I am taking minus V as common. 1 by R1 plus 1 by R2 is equal to I. Any doubt in this? I am just playing with the equation, that's all I am doing here. Okay, now this one, take it to the left hand side of the equation, and this I take it to the right hand side of the equation. So how the equation will be? V into 1 by R1 plus 1 by R2 is equal to E1 by R1 plus E2 by R2. That I, which was there in the left, will be coming this side, minus I. Any issues? No. Now I am going to take 1 by R1 plus 1 by R2 to the right hand side of the equation. So this will be dividing entire equation on the right. So this will be V equal to E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2 minus I by 1 by R1 plus 1 by R2. One more step, last step, E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2 minus I. Tell me what is 1 by R1 plus 1 by R2? R1 plus R2 by R1 R2. वो R1 R2 ऊपर आ जाएगा. R1 R2 by R1 plus R2 is V. Can you see this, everyone? So this is the equation for V. The potential difference across a parallel combination of cells is equal to E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2 minus I R1 R2 by R1 plus R2. Just compare this equation of V, okay, with the basic equation for potential difference across a cell. What is it? What is the formula for potential difference across a given cell of EMF E and internal resistance R? E minus IR. Yes or no? Yes. This is the equation of net potential difference. Compare it with the equation of potential difference we got. V here, right? E here, and what do we have? This much big combination of formulas. So what does that represent? If you compare these two equations, we can say that E is equal to E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2. Similarly, E minus I here, and here we have R, and R is being represented here as R1 R2 by R1 plus R2. So if two cells are connected in parallel with an internal resistance R1 and R2, the equivalent value of resistance R is equal to R1 R2 divided by R1 plus R2. This you can rewrite this as 1 by R is equal to 1 by R1 plus 1 by R2, isn't it? 1 by R is equal to 1 by R1 plus 1 by R2 will be giving you the same equation. Or Q. So now we know the formula by heart, and now we know the concept which is actually leading to the derivation of the same formula. हाँ, the question तो ज़रूर देगा, but your concept should be so firm that whatever question is given to you, you should be able to solve it, isn't it? Yes. जल्दी से बता दे, समझ में आ गया? हाँ, समझ में आ गया सबको? Everyone? Yo. And how many of you, even without me telling you, noted down this entire concepts and all the steps and the final formula? When EMF connects in infinitely, we'll discuss, okay? आ गया तो आ गया, समझ में आ गया, मुस्कुराहट भी आ गया, है ना? और क्या? Can I give you a simple short note, a small case, a छोटू सा case? Okay, देख ले. This cells है ना, which we are connecting, let's say if they are of equal value, equal EMF, equal internal resistance, equal EMF, equal internal resistance. Let's see what is the EMF going to be. The net EMF going to be how much? Let's see. It is going to be so much interesting. Formula E1 by R1, that will be E by R, plus E2 by R2, that is also E by R, because both the EMF and internal resistance are same. 1 by R1 हो गया 1 by R, 1 by R2 हो गया 1 by R. How much is it? 2 times E by R by 2 times 1 by R. 2 by R cancel E, which means cells of equal EMF are connected in parallel. The net EMF is going to be the EMF of a single cell. Very important, super important, please do mark it, okay? I will be telling you, mark it, it is very important matlab super important. And what is it? If cells of equal EMF are connected in parallel, the net EMF is going to be the EMF of a single cell super. Great. And I think I don't need to explain you to find out the equivalent value of resistance. 1 by R equivalent is equal to 1 by R1 is also R, 1 by R2 is also R. This is 2 by R is equal to 1 by R equivalent, or R equivalent will be equal to R by 2. Matlab, if two cells of equal resistance, internal resistance are connected in parallel, equivalent internal resistance is R by 2. So if n number of such cells are connected, what will be the equivalent internal resistance? R by n. Note it down. Okay. In general, if equal cells, equal EMF and internal resistance are connected in parallel, the equivalent value of internal resistance will be equal to R by n. N is the number of such parallel combination of cells. Okay. So this is very, 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 very important. And let me know once you complete this. बोल दे, those who have completed, tell me, हाँ सर बिल्कुल हो गया, हो गया. So क्वेश्चन करने के लिए रेडी, रेडी है या नहीं, रेडी है या नहीं, जल्दी बोल दे. If you say we are totally ready, I'll show you the question, but I want to see that energy and that full josh in the class. H2O is very important, that's why I am drinking in between. Actually I was having 4 classes today, 4 classes matlab 4 classes, and on top of it I have told to some of my students which come to my classes regularly, I was totally sad today. Do you know the reason? Because my cycle, okay, which I supposed to go to my gym, which I used to go to my everywhere, you know, it was one of my good companion. So एक चोर ने आकर चुरा दिया पता नहीं कितना गाली दे दिया उसी टाइम. अभी तो क्लास है, I can't say all those things but I was super sad for the past 2 days, and I was, हाँ, some of you might be knowing, and I have told in other classes. So मुझे भी बहुत दुख हो गया था. अरे क्या करूँ. So hope that police people will be finding me that cycle for me. हो गया तो हो गया, और क्या करूँ. हाँ, मेरा अच्छा वाला साथी था. Actually I used to go after this class है ना, which means after 11:30, after I go back from office to my home, I usually take my cycle at night time, 12 o'clock. I'll be taking it, I'll be going for a ride at night time, because in Bangalore the weather is so awesome. Then there will be natural ice cream shop. I'll be going there and I'll get a scoop of tender coconut ice cream. Wow, night will be made, it'll be awesome. But anyway, I don't know how to go from now onwards. I was also having the same kind of feeling, Sanjana, but what to do, कुछ नहीं कर सकता. Anyway, आजा, let's proceed and start doing this question. Everyone, come back. Okay, first 2 options are not visible, right? I'll put it for you. This is 1 volt and option C is like a 2 volt. अब कर ले. मेरा मज़े, अरे I'll start my job from the morning till 11:30. इधर मज़े का बात क्या है बता. But it's a good thing that I'm spending time with all my students and I'm doing a job which I love, which means the teaching, I love it the most. So good. I can see people giving me the options as option B, which is Harjot, Saurabh, then Saurabh, Riya, everyone is giving me option B. Okay, let's see whether the option is B or something else. Yes Miara, yes. Okay, so shall we find out? Okay, so the question is find out the net EMF. Here how many cells are there? 3. Okay, if you know the equation to find out the EMF of 2, obviously you can expand it and find out the equation for finding out 3, है ना. और क्या सर, बिल्कुल. फॉर्मूला नेट EMF is E1 by R1 plus E2 by R2 plus E3 by R3. Here there are 3, the whole divided by 1 by R1 plus 1 by R2 plus 1 by R3. Just substitute the value, add it up, get your answer. E1 is how much? 3, and all are having the same internal resistance of 1. Then E2 is 2 by 1, E3 is 1 by 1, the whole divided by 1 by 1 plus 1 by 1 plus 1 by 1. अरे हो गया 3 plus 2, 5 plus 1, 6 divided by 1 plus 1 plus 1, that is 3. 6 by 3 हो गया 2 volt. So option C is our answer. Simple. देख ले कितना simple है. Find the net EMF of the combination of the cells. हो गया हमारा काम. Any issues if anyone is having, let me know before we proceed. कोई गलती नहीं है ना. Okay, now same question. Let's say there is a small difference in the question, which means can you see the cell E2? Instead of connecting it in the same order like this, like a positive towards left and a negative towards right, the cell EMF, let's say it is connected in the opposite order, matlab ऐसे, or we'll draw it with a different color so that we can notice. The E2 is connected in this fashion, where positive is at the right and negative is at the left. In this case, what change can we observe in the equation for finding out the net EMF? Very simple. It is E1 by R1 positive, E3 by R3, that is also positive because both of them are in the same order. E2 is in the opposite order, so there will be coming a simple negative sign there with E2 by R2. That is the only difference when one of the cell ऐसे उल्टा करके, मतलब if one of the cell is kept in a different order. Okay, almost everyone said B है ना. हाँ, so the option is 2. What was the reason for everyone to choose B? Was there anything, or is it like the first person gave the option as B? Okay, thinking that whoever gave the answer first, हाँ उसको तो पता ही है. So let me also copy the same thing. ऐसे ही? I don't think so. ऐसे दे दिया क्या? है या नहीं? ना, है ना? So I have no idea. Okay. So देख ले, I am the odd one out, and you know that always the odd one out stands out. Okay. You said 2V, अरे आना, I didn't see that anyway. Good. You just assume. अरे बाप रे, जिंदगी ऐसा भी हो गया क्या? This is a very beautiful question with the concept. Let me see how many of you are gonna give me the answer. This is ohms, 1 ohms. Question देख ले. Let's read all this question together. Okay. Two similar cells, whether joined in series or in parallel, have the same current through an external resistance of 2 ohms. अरे बाप रे, ये कैसे? Okay. Question is, if this condition is being satisfied, what is the internal resistance of each cell? Everyone, go for it quickly. Simple, very simple. I know that everyone is going to give me the answer. Jaldi se jaldi, turant se turant, है ना? Any answer? Karanjit says option D is 2 ohms. Karanjit says D. Agni says A. Harjot says option C. C है क्या इधर? हाँ, C भी है. The only option कोई option left है क्या? B, D, A नहीं बोल दिया no one. हाँ, A भी आ गया अग्नि का. C है, D है. So anyone, why don't someone choose B also? अरे यार. Okay, so the correct option is D. Whoever gave the answer as option D, बढ़िया. सर आज का स्मार्ट बच्चा कौन है? कोई भी नहीं, सिर्फ मैं हूँ. अरे देख ले. Let's find out how this is done. Okay, two cells. Okay, when they are connected in series, let's say one of the cell internal resistance, another cell EMF E, its internal resistance R. Okay, and it is connected to an external resistance of 2 ohm. Let's find out the equation for current here. Current is equal to total EMF. E plus E हो गया 2E by total resistance is R plus R, 2R plus 2. So the current in the first case is this. Okay, let's go for the current in the second case. Cell internal resistance, cell internal resistance connected in parallel across an external resistance of how much? What is the external resistance here? 2 ohm. Okay, R R E E. Tell me what is the formula for current here in the second case. This is I dash, let's say. Two cells of equal EMF connected in parallel. You all know what is a net EMF. It is E only. We already have discussed, right? Okay. Divided by total resistance. Ye R and R connected in parallel. Okay. Equal cells of equal resistances connected in parallel. Equivalent values are by N. N is the number of parallel connection. How many are here? 2. So this is R by 2 plus 2. This is the total. It is given that the current in the first case and current in the second case is the same. Shall we just equate it and get the answer for R? Or kya kar le? So what is current I? 2E by 2R plus 2. Shall I write? 2E divided by 2R plus 2 is equal to, it's given in the question, okay, current in the first case is equal to current in the second case. What is current in the second case? E divided by R by 2 plus 2. अरे हो गया काम. Okay, what is there left? कुछ नहीं. E cancel कर ले, हो गया. Cross multiply, 2 times R by 2 is R plus 2 2s are 4. Then 2R plus 2. So 2R minus R is R, 4 minus 2 is 2. R का value मिल गया 2. 2 ohms. देख ले, सिंपल. कितना आसानी से मिल गया हमको आंसर. ओके, यही होता है. This is the benefit of learning. This is the benefit of learning physics with full of concept and with that passion towards learning physics. मज़ा भी आ जाएगा, सच में बोल रहा हूँ मैं. Shiv Prasad Chandran, I can feel Malayalam accent in you. Thank you so much, because I am from Kerala. Thank you so much for recognizing my place. Okay, so is the concept clear? Any doubts? Anyone? Done with a smile on your faces, with a super amazing cute happy wala smile. आ गया तो आ गया, समझ भी आ गया. Yes. Okay. Good. So okay, next is grouping of cells. This is another important and let's say one of the amazing topic. Okay, this is so much fun to learn. Now we know all the concepts of a series combination of cells. बोल है या नहीं? हाँ sir, बिल्कुल हमको पता है. बोल हाँ. Then we also know the concepts of parallel combination of cells. That also we know. Now we are having the combination of series and parallel, and here we are asked to find out the equivalent value of EMF, equivalent value of internal resistance, all these things. Shall we? Look here. So in the mixed grouping of cells, here we are considering the simplest case where all the EMF and internal resistance are having the same value. Okay, done. Then what we have is, here in this particular case we are having different rows. Let's say the number of rows is equal to m, and in each row n number of equal cells are being connected. Okay, now tell me, if n number of equal cells are connected in series, what is the equivalent EMF? E plus 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 E plus, अरे सांस नहीं आ जाएगा, n times E, isn't it? What about internal resistance? Put it as small r, not big R. Okay, so internal resistance in a single row is R plus R plus R plus R plus R plus R. कितना R? हाँ, that will be n times smaller. And this is about one single row, and we have m times such single rows of same EMF and internal resistances are there ऐसे connected. Okay, yes, yes or a no? Yes, isn't it? Now it is very much easy. Now you can see that m rows are there, m parallel connection of cells are there, where each are having equal EMF. We know that when cells are connected in parallel of equal EMF, the net EMF is going to be, the effective value for EMF is going to be the EMF of a single cell, which is Ne. Even though there are m rows of cells, it is not going to make a difference, because all are connected in parallel, all are having the same EMF. So the effective EMF is going to be the EMF of a single cell, which is Ne. We already have discussed this. Don't say no. Don't say no. We have discussed. Isn't it yes or no? बोल दें हाँ sir, बिल्कुल. Yes. Next. So effective value of EMF is done. So now you can see this NR resistance, NR is connected in parallel. Okay, how many such connections are there? M such number of connections are there. So what will be the equivalent value of internal resistance? That is NR divided by M, because M number of such rows are there where each are having NR as its internal resistance. So R equivalent will be NR divided by M. So if this combination is connected to an external circuit of resistance R, what will be the current passing through it? Current, total EMF kitna? Ne divided by total resistance. How much is total resistance? NR by M, which is total internal resistance plus the external resistance R. हो गया. जल्दी बोल दे, समझ में आ गया तो give me a smile in the chat box. Give me a smile in the chat box if you have understood this particular concept. Jaldi, 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 jaldi. Yo. Give me a smile. Yes, Ria, I can see the smiling face. Vanshika. You're going to Thrissur on 20th. Very good. Why you have to be crying for that? It's a happy moment. Hasle. Have a smile on your face. Understood, Palak. No doubts. कुछ भी नहीं, कोई डाउट भी नहीं. अरे बाप रे. अब सब लोगों को समझ में आ रहा है ना? I'm not able to find any doubts. Because you know that no doubt condition will also be there when you don't understand anything. You will be like, अरे क्यों पूछना है डाउट, कुछ भी नहीं समझ में आ रहा है. Understood. और क्या तो थोड़ा क्वेश्चन करेगा. Why don't we do some questions? इंटरेस्टेड है आप लोग? इंटरेस्टेड है क्या? बोले इंटरेस्टेड है तो बता. We can start doing some problems. अरे इंटरेस्ट तो होना ही चाहिए. एग्जाम्स आर कमिंग. बुद्धू लोग जल्दी से कर ले. ओके, हियर वी गो. समझ आ रहा है? ओके, सो लेट मी सी हाउ मच यू हैव अंडरस्टूड. आई राइट डाउन ऑल द रिमेनिंग ऑप्शंस. ऑप्शन ए 6 वोल्ट 2 ohms. ऑप्शन सी 9 वोल्ट 4 ohms. बस लेट्स डू इट. हियर वी गो. जल्दी. Shiva Prasad, questions weird. Oh my god, I can see that typical my Malu friend. Shiva Prasad, good to have you here. Because my friends also use this weird word all the time. Is anyone of you gonna give me the answer? Three cells are there. Nobody with the answer. How many cells are here? First cell, second cell, third cell. Agni says option D. Okay. Others, any other options? Let me wait for मेरा डिजिटल बोर्ड कुछ तो हो गया भाई क्या बताऊँ, 2 days before I was about to take the classes, so I was like कुछ नहीं काम हो रहा है. So I hope for tomorrow things will be all right. अरे ठीक है भारत, और क्या. Okay, last 5 seconds to answer. 5, 4, 3. Agni says option D is the only person who gave me the answer. 2, 1, and done. I can't see any option. So yes, the correct option is B. Let's see how this question can be done. First, find out the equivalent EMF of this combination. Okay. Before going, check how the cells are connected. Aren't they connected in the opposite direction? Yes or no? Yes. So you should be very careful while doing this problem because signs are very important. I am considering the cells in this direction to be having a positive sign. So Karle, net EMF of parallel combination is E1 by R1, 10 by 2. This 4 is connected in the opposite, so minus E2 divided by R2, the whole divided by 1 by R1 is 2, 1 by R2 is also 2. So this is 10 by 2, that is 5, minus 4 by 2 is 2. So 5 minus 2, this is a 3 by half plus half is 1. Okay. So these two cells which is combined in parallel will be producing a net EMF of 3, and what is its sign? Plus. Plus means SA, which means negative here and positive here with an equivalent value of 3. What is an internal resistance? 2 and 2 connected in parallel. 1 by R is equal to 1 by 2 plus 1 by 2. So ho gaya 1. So internal resistance is 1. This is connected in series to another cell of 6 volt and 1 ohm SA. Tell me, ye 6 or ye 3 connected in series, same order or opposite order? Opposite order. So net value is 6 minus 3, that will be 3. Okay, 1 plus 1, 2 ohms. Ho gaya answer. Okay, yes. Okay, so many of you have given the answer in between. अरे बाप रे, I think मेरा इंटरनेट थोड़ा स्लो है और कुछ गड़बड़ था in between. Right, the correct option is B actually. Okay, very good. It's my mistake. Seems like I missed the answer from many of you. Okay, so anyway, I hope you all got it. Okay, so we are gonna stop here for the time being because this is my 4th class continuously and my gala is gone. I thought I'll take class till 11:30, but already हो गया, ज़्यादा तो नहीं हो जाएगा अभी. So we'll stop here and this है ना, so this we'll be doing tomorrow है ना. One more question is there. मुझे थोड़ा भी एनर्जी नहीं है. I started my class at 4:30. अभी कितना हो गया? 11:08, 11:10 कुछ हो गया है ना, बहुत ज़्यादा हो गया. Thank you so much. Thank you so much. तो बोल दे, how many of you gonna come to the class after doing the revision? Before we go, Agni, Vanshika, Palak, thank you so much. Who will be coming after doing the revision? Ha. Thank you so much for those concerning words, Anna. Thank you so much. Okay, so I'll have Sanjana who will be coming to the class after revision. Thank you so much, Miara. But before you go, promise me you'll be coming with a revision. Bharat promise me, yes. Agni promise me. Sudeep promise me. Very good, Anna. That's the amazing promise which is coming from your heart. I can see that. Good. Thank you so much, Miara. Thank you so much for that caring words. Okay, so Palak, Riya, I think I want every one of you, and please try to do some extra multiple choice question also from these topics of combination of cells. Okay, so that no one can defeat you by putting a hard question from this topic. Okay, so make sure that you are doing some extra multiple choice question also. So one small task I am assigning to you. Okay, this is the new class, the new batches which is going to start. One small thing is like how many of you are going to, let's say, share the class with your friends and ask tell this your friends that अरे मेरा भाई और मेरा दोस्त Ameer sir का class है which will be happening for 12th standard at 10 p.m. and for 11th standard at 8 p.m. Why don't you also come? How many of you are going to do that? हाँ, share करके how many of you are going to ask your friends also to come and join? Very good, Sudeep, amazing. Palak also. Miara will be back with the revision. So I hope you can do this to help for me in this particular case. Okay, so share the session, this particular session and tomorrow's session, and whenever you come to your session you can post the class in your school groups, okay, in your friends group, and ask your friends also to come and join. Okay, it will be a great thing for me. And do leave the class by liking the class. Okay, a small appreciation you can do from your side, telling that sir आपको हमको अच्छे से समझ में आ रहा है, you are doing a good thing. And yes, the only way you can express is by putting on that like button. And for any subscription you make, don't forget the code is AMB10, and as you all know, triple dhamaka offer is going on. This is the best time so that you can make the subscription and enjoy a lot many offers going on. So thank you so much everyone. I'm going to sign out with Unacademy. Bye everyone, take care, and let's crack it like all the time. Okay, so take care, bye everyone. Agni already like, thank you so much. Bye everyone, take care, have an amazing